Hi, this video will show you the tutorial for level 0 of week 1. So after fetching all the labs by running fetch week 1, then you will see this kind of the directory structure. Let's go to level 0. And the end goal of this challenge is that you need to read the flag, but right now we don't have permission because we are not in the group ID of that challenge, for example. So if you do this, then to read the flag, you need to get the privilege of like a week 1 level 0 solved group privilege of that. Yeah, but right now we don't have that group privilege. Yeah. So what we need to do is we need to understand how level 0 binary works and try to get the privilege of this program while running this program and read the flag. And let's do that. And as a first step, we need to get the disassembly of the level 0 because we don't have the source code for that. So first, we will run gdb level 0. And to get the disassembly, just run the command this as main. And we can easily get all the disassembly like this and just copy all the text. And we will create a text file, disassembly.txt, and paste it. So now we have this assembly, and we will use tmux to split the screen into two to see the GDB and the Vim window side by side. So to use that, just run tmux. And I put some of the commands on the slide of the tmux. So if you click the backtick and the %, then you can split the terminal into two. And on the right side, I will open the disassembly.txt. And on the left side, I will run gdb. So this should be like some of the general settings that I recommend for you guys to use. And let's start reverse engineering. So as you can see from this slide, we will first focus on what kind of call instructions are there, and we will break the lines after the few call instructions. And then try to analyze this first. So the first instruction to analyze, so because I just skipped these three instructions because it's a function prologue to move ESP and EBP. So we can this kind of the instructions are always be there at the start of the function. So it's about reserving the local variable. So it will use this amount of like the 0x228 is around like 600, 500 something bytes, yeah, on the stack. So you may ignore these three instructions, and then let's start reverse engineer the first function, printf. Yeah, printf is here. And the first instruction is LEA. It's a load effective address, and this value, 0x80486E7. It does not have dollar flag in front of this, so no dollar prefix, so this is an address. But the Intel assembly regards address as getting the value of the address, but because the instruction is a load effective address of this value, so it will be just the address of 0x80486E7. And the destination register is EAX, so EAX will store this value. That's the meaning of this instruction. I will try to translate the C-like pseudocode that you guys may understand because assembly is not that human friendly. And then the next instruction is EBP -4 will be 0 because it's a move instruction, so it will put 0 on the EBP -4. But here, because negative addressing indexing over EBP is a local variable, so please refer to this lecture slide. So this is the green part, so you can just put some of the name of the local variable as EBP minus 4, and put the value 0 on it. And the next instruction is ESP, and the parenthesis means the differencing. And the differencing index there's nothing about the index, so it means 0. So we can say ESP0 will be EAX, and then the value of EAX is 80486E7. And then it calls printf. And for the function arguments, so starting from the ESP, we get the first argument, ESP plus 4, which is ESP1 as an integer pointer index. That will be argument 2, 3, 4, and on. So the first argument of the printf will be 0x80486E7. Then the important thing is that what's in this address. And that's why we have a GDB screen at here. So to get an idea of what's in there, and we know that the printf gets some of the character pointer as a string as an argument. So based on that knowledge, then we can try to examine that address as a string 80486E7. Then the string is what's the password. So you can regard this function is called as like this. So we just finished the first call, printf. And let's move on to the second call, scanf. I'm just doing the same thing about what I explained on the lecture note, and then this will demonstrate how you can actually do the reverse engineering. Yeah. So the next one is the LEA. This is an address, so we just put that address to ECX. So ECX will store 0x80486FD. And then the next one is EDX will store EBP minus 204. But then the important thing here is that, so previously, when we encounter this, we put 0 to EBP minus 4 as a local variable, because the instruction was move. But right now, the instruction is LEA, load effective address. So what we need to do is we need to take the address of this local variable and put that to EDX, source, destination, and we will take the address of this source to the destination. So we can interpret this line as this kind of the C pseudocode. And then we put ESP, the reference is 0 as ECX, which is 0x80486FD. So it was assigned at here. And then ESP, so the size of the integer is 4. So index as a 4 is just 1 as an integer. So, and then we put EDX, which is EBP minus 204, address of that, to ESP1. And we may ignore this line. You can interpret this as EBP minus 208 as EAX, but because the entire function does not use this value at all, so you can ignore that. And then next call is scanf, and the first argument is ESP0, which is 0x80486FD, and the second argument is EBP 204 as an address. Then the next curious stuff is what's in the 80486FD. And then do that again, because scanf always take this argument as a character pointer, so we know that this is some of the string 80486FD, so we will examine that as a string. It's %s. And we can rewrite this as scanf %s EBP minus 204. Yeah. This is simple, so what you can do is just follow the assembly line and translate that as a C code. Then next is ECX is load effective address, the address of EBP minus 204. And then this is quite weird because like the binary is not compiled with the optimizer, so it has some of the not that efficient code. So EDX stores ESP as an alias, and then EDX0 will be ECX. But now we know that EDX is equal to ESP, so this is equivalent to ESP0 will be ECX. And then next thing is EDX4, but we know that this accesses as an integer pointer. EDX1 will be 0x80488700, but we know that ESP1 will be this, because EDX and then ESP will point to the same address. And then you can also ignore this line. This is actually EBP minus 2OC is EAX, but the function will not use that. And after that, it will call strcmp. What's the first argument? ECX. ECX is actually the address of EBP minus 204, which we will put some of the string on it from our input based on this function scanf. And then the second argument was this one. Then let's see what's in there. Oh, it's some, looks like a password. So just put that at, yeah. So now we finish it up to like reverse engineering the up to this point. And then the next instruction is a compare and jump. So whenever you encounter compare and jump, this is actually jump not equal, then you can regard it as creating an if condition. Yeah. And creating an if, and then it compares 0 to EAX. And there's a special use case of the EAX register, and that is it will store the return value of the function that is just called right before of this line. So EAX will store the return value of the string compare. And the semantic of this string compare is that it will return 0 if toString is equal. So we see the compare instruction here, and the EAX is the result of the string compare, so we can rewrite this instruction, these instructions as a C code like EBP minus 204 and PASSW0RD is not equal, because jump not equal, right? And then which value it was compared to was 0, right? Yeah. And then jump not equal says it will jump to main plus 127, so we will get main plus 127 till the end into this, and then we will create else condition, and then we will put these instructions into else. And after you create if and else, take a look at the last line of the else. It says jump to main plus 147. That means like the starting from 147, it will be the common part. Regardless of like the result of the if condition, it will execute this, and then this code will execute 147 to 157 too. So what you can do is like these are common parts, so you can get it out. So the execution flow is like the if this is not equal to 0, it will execute the these part, and then else it will execute these parts. And then after constructing if condition like this, you can do the same thing. And then now you know that this will goes to EAX, and EAX goes to the first argument of the printf, so it will be printf. And then to get the address of this one, so we know that the printf stores a string, so it will say wrong password at here. And then this one, This one is also printf. And then what's in here? Correct, right? And then it will just call get a shell. Now let's finish it. So we just finished the reverse engineering of the level 1, and then let's try to combine all the C code and try to look at the pseudocode of it. So I will just copy the entire code here and then try to remove all the assembly and the non-relevant parts. So these are all for analyzing the printf. We can remove all the things, and then we just get this printf. And then second call was the scanf, and then we know how it is being called. Remove it, then we get scanf. Then third call is about the string compare, but we know that this is about the if condition. So we will just leave this. And then in the true condition, we will get this. And in the false else part, we will get these lines. Oh, sorry. Yeah, this is quite short code. And can you get how to get the password? So it will ask what's the password, and then scanf. So we need to input something, and based on our input, if we put this string, then it will say correct and get a shell. Let's try level 0, and we will put this, then it says correct and spawning a privileged shell. And then to check the privilege, you can type ID, then now we have a GID like this. And after doing this, cat flag, you can get the flag. And please don't forget to put this flag into our scoring system. Thank you. This is the end of the tutorial for level 0.